Check him out, Ian Webster. I mean, how old is this person? And of course, if you were to come and visit Moon Express at the Ames field, you'd see that it's primarily staffed by children. Yeah. And the other thing that caught my attention about Ian is this headline I came upon at the Daily Mail, but it was reported all over the world. Ian Webster's created an amazing thing, which is a ranking of astronauts. And there's some 600,000 of these objects floating around, I guess, in relative proximity to Earth, ranking them by profitability. So the headline says, single asteroid worth 60 trillion if it were mined as much as the world earns in a year. And the subheads read, new site Asterank ranks asteroids for profitability, uses available NASA information, ranks accessibility versus profit, single asteroid has 95.8 trillion of minerals, comes in wake of announcement of company backed by James Cameron, that's the Planetary Resources. First flight trials planned in 2 years, plan would add trillions to the Earth's GDP. Okay, coming up here, Ian.
So I'm sure a lot of you recognize this picture. It's one of many famous images of the skies over Chelyabinsk, Russia on February 15th earlier this year. Now that morning, a huge fireball lit the sky. An asteroid, a rock, about 17 to 20 meters in size, weighing over 10,000 tons, hit the Earth's atmosphere, exploding with the power of several atomic bombs. Now, for a lot of people, waking up in the morning and seeing these headlines was the first time in a while they thought about asteroids or outer space. For many, it was a jarring reminder of how fragile our planet can be. But for people like me, and scientists and astronomers, this is something that we think about every day. And I'm going to talk to you today a bit about the work that I've been doing to organize and analyze the information that we have on these objects, as well as to discover new objects similar to the one that exploded over Russia. And I'm also going to introduce you to a new concept, asteroid mining, which sounds a lot like science fiction, but is actually pretty close to becoming science fact. First, some background. Asteroids are rocks in space. They range from anywhere between a couple meters in length to hundreds of kilometers in diameter. And most of them reside in what's known as the asteroid belt, or the main belt, between the orbits of Mars and Jupiter. The ones, though, that scientists and astronomers are most interested in are near-Earth objects, or NEOs. And a subset of these near-Earth objects are classified as potentially hazardous objects. About 1,300 of them, 1,300 of them, have orbits where there is a probability that they'll intersect with Earth. And the thing about the Russian meteor is that it wasn't a freak accident. We know that it'll happen again, but by discovering and tracking these objects, we can make sure we're prepared for an event like this. So planetary defense is one of the big reasons why we're investing in discovering and tracking asteroids. The next reason is a little more nuanced. Asteroids are not just big existential threats. They are the remnants of a primordial universe, one that formed over 4 billion years ago. And in fact, a lot of the same basic building blocks of the Earth we find in asteroids. So materials, substances like hydrogen, nitrogen, oxygen, water, and various silicates are all present in asteroids. And the way that scientists classify asteroids is by determining their material composition, by looking at the way that asteroids reflect light. And as a result, we know that asteroids are very high in platinum group metals. They contain about 100 times the concentration of platinum group metals than we find in the Earth's crust. And they also contain other metals like nickel, iron, cobalt, and magnesium. As a result, asteroids are a critical part of any 21st century space economy. The reason for this is really simple. It's extremely expensive to get into space. It costs over $4,000 per kilogram to get materials from the surface of the Earth to low Earth orbit. And this is not going to change that much anytime soon. These high launch costs are what's hamstring the space exploration and space industries. And it's the reason why we haven't seen that much difference in space exploration in the past several decades. So the idea then is to use what we already have in space. We know that there are vast, unprecedented amounts of natural resources locked up in these asteroids that are already in space. By mining these asteroids, we can circumvent these extremely high launch costs. And they contain things like water, a substance that's essential for life, also very useful for radiation shielding. They contain all the components of rocket fuel. And they contain building materials. So they contain these rare earth metals and general building materials that are very useful. And just to give you a sense of the scale that I'm talking about, a single platinum-rich asteroid contains more platinum than has ever been mined in the history of humanity. It would more than double the Earth's platinum supply. And these other rare earth metals are used in about 1 in every 4 manufactured goods. So you can see here that there's a huge opportunity to transform space exploration and space industry and really change the way that manufacturing is done. And you don't have to take my word for it. About a year ago, a company called Planetary Resources was announced with the backing of several prominent billionaire investors. And they've made great progress toward getting their first asteroid hunting space telescope in space by sometime next year. And there's competition in this industry. So there's an entire asteroid mining industry that's being built from the ground up. Last fall, Deep Space Industries announced their intent to do to have a similar approach to asteroid mining. So where do I fit into all of this? Well, I'm a computer scientist by training. So at school, I learned a lot about computer science theory, algorithms. At work, I do a lot of stuff related to infrastructure and figuring out how to represent large amounts of data to people and let them interact with it. So I set out to find a way to apply my skills in computer science to a difficult problem in space, because that would be really cool. And with over 500,000 asteroids that we know about, it becomes very difficult to answer simple questions, ones like which is the most valuable asteroid, or even just general space exploration questions like which asteroids are the easiest to get to, or which large asteroids are going to come by the Earth over the next couple of years. So my goal then was to create this platform where I would take all the data in the world that we have on asteroids and put it under one roof. And this project is called Asterank. Asterank is a platform that lets you ask questions about space and get answers. It's what companies like Planetary Resources and Deep Space Industries are going to use to determine which asteroids to mine and why. And aside from being one of the most comprehensive asteroid databases in the world, it's also a platform that is made for you guys. It's made for public engagement. And I'm also going to talk about how it enables people who are interested in this science and who want to get involved to understand the work, the science that's being done, and also contribute to actual ongoing scientific processes. In order to make this all happen, I needed to collect a lot of information. So sort of like how Google goes out and crawls the web, I go out and crawl a number of scientific data sources. Sources like NASA, the JPL, the Minor Planet Center, and probably about a dozen other minor sources and various scientific papers. I pull in all this data every night. The next step is to bring in global commodities markets, like the London Metals Exchange, so I can actually figure out how much this stuff is worth. Now that I have now that I've gathered all this data, I have what's called a unified data model. It's my ground truth for all the information that we have in the world on asteroids, all in one place. And I run a number of calculations over it. So my calculations are typically smaller mathematical functions that tend to answer some of the more bite-sized questions that scientists have. And when you put it all together, you wind up with something that looks like this. So this is the data view that answers the question, which asteroids are the most cost-efficient to mine? Which asteroids give the greatest return on investment? And I know the numbers that you see here are really big, right? Big numbers. These are theoretical maximums, right? So they're supposing that we mined every last bit of the asteroid at the current market value. But I think the really interesting thing about this is it gives you a ballpark idea of what's out there. It's a really humbling sort of indicator of the vast amount of potential out there. Now, I'm a more visual guy, and this looks like an Excel spreadsheet. So being a computer programmer, I turned to a technology called WebGL. Now, WebGL is something that will run in your laptop. So you can just go home, open up your browser, and view the simulation. And this simulation is tied directly to my database of over 500,000 objects. It's scientifically accurate, and it shows you everything that's out there and the result of a lot of the computations that I've done. I think it's super useful to be able to move around the solar system to see the context of all these objects, and really helps, I think, understand and engage with what's out there. So this is the view of the most cost-effective asteroids, so the ones that give the greatest return on investments. My favorite view, though, is the accessibility view, which we're going to switch to in a second. And what it means for an asteroid to be accessible is that it's cheap and easy to get to. And the mind-blowing thing here is that there are over 1,700 asteroids, 1,700 asteroids that are easier and more accessible than the moon. I think that's remarkable. And if there's one thing that you guys remember from my talk, if you're zoning out, pay attention, because I want you to remember that space is not empty. Space is absolutely chock full of these opportunities of natural resources, of asteroids that are all easier to get to and more within reach than the moon was 44 years ago. It's a simple, amazing fact. The visualization is not just a toy. When you couple it with the data view, it becomes a powerful resource to be able to apply context to the visualization. So it lets you answer questions like, which asteroids are going to skim the Earth next? And we'll see that in a second. You can see all the asteroids clustered around Earth, and then they spread out again. So a useful way to browse the objects that we may have a close encounter with. Also answers questions like, which objects are the smallest? So for any of you who have been following NASA's latest initiatives, they're interested in nudging the orbits of small asteroids. I thought all this stuff was pretty cool. But someone told me that, you know, Ian, there are a lot of asteroids out there that we don't know about yet. And in fact, the mind-blowing thing here is that there are millions of asteroids that we don't know about yet. They're out there, we just don't have the information and the observational data that we need in order to track them. So, I guess I'll add that about 17% of these, if we extrapolate, are easier to get to than the moon in terms of the energy required to reach these objects. So I'm going to talk a little bit about the way that asteroids are discovered today. Today, asteroids are discovered by these big sky surveys. They're typically centered around universities. They're government funded. And they do a pretty good job. They discover asteroids at a rate of about 1 or 2 asteroids per day, which is pretty neat. By now, you may have noticed that I'm not a grizzled old astronomer. I don't have a PhD. So I wanted to find a way to put this process of asteroid discovery into the hands of people like you and me. I wanted to be able to directly engage with this scientific process. So I took 700,000 images from the Near-Earth Asteroid Tracking Sky Survey and built an application that shows these images to people. Now, right now, these asteroids are typically discovered in imagery by computer algorithms. And the algorithms do a pretty good job, 1 or 2 asteroids per day, but we know for a fact that there are asteroids that are missing. We know that humans do a better job of spotting asteroids in imagery than computers. So what I do is I show people short animated movies of the night sky, of observational data, telescope data, and it turns out it's not that hard to pick out asteroids from imagery. So I'm going to give you guys a vision test. This is someone using the application, and I don't know if you guys can see, but there's a dot moving that I'm pointing out in the video, and that's an asteroid. So the way that asteroids show up on images of the night sky is that they're moving dots on the static backdrop, against the static backdrop of stars. So it turns out that it's more or less straightforward to discover asteroids. We just need more eyes and to get more people involved. And I think the really fun part is that if you're the first person to spot this moving dot in the imagery, it means you get full naming and discovery rights. You get to name the asteroid after yourself or after your mom, or anything that you name the asteroid. So it's pretty neat. Where is Asterank going? Well, I'm a huge believer in the freeness and openness of scientific data. I'm incredibly passionate about the fact that normal people, someone like me who's just naturally curious about this sort of stuff, ought to be able to directly browse, get involved with, and look over the data that scientists are collecting. And to this end, to sort of put this capability in the hands of normal people, I completely open sourced the project. So everything that I've shown you in this presentation is available online. And it means that if you're a developer, if you hate it, you can improve it. If you love it, you could do even more. You could check my math. You could do anything that you want with the source code that I did. And I'm just going to end by saying that I think that right now there's a misconception that space is just a hardware problem. Space is rocket science. But that ignores the fact that there are incredible amounts of data that we have on space that are not being analyzed because we lack the software resources to do it. There are terabytes of imagery, sky survey imagery, that have not been reviewed by human eyes because we don't have a way to present it to people. And as private industry goes into space, as they start collecting and generating data, there's going to be a dramatic increase in the amount of information that's being collected. So there's a huge opportunity for scalable, principled software approaches in space. And to this end, Asterank was recently acquired by Planetary Resources, and I'll be working with them to continue to organize and analyze and discover new asteroids. And it's my hope that by supporting this open program of public engagement, I can inspire and empower a generation of people who are going to go forward and make this 21st century dream into a reality. Thanks.
So, how old are you, Ian?
I'm 23.
Wow. Bravo, let's have our picture.